Hello, hello, hello.
Yeah, Salim, can you hear me?
Yes, yes, yes. I'm audible to you.
Yeah, yes.
So you have some problems with trigonometry function, right?
Yeah, correct.
So today I just tell you about those functions.
Trigonometric and the sum 5 and 6. And 5 and 6 I need to add only for the equation or like
Five
the
and
expression.
six.
Yeah,
Okay. That is y is equal to a into b into c
yeah, yeah,
plus
into
d.
yes.
Okay, okay. So right now I just share my window to you. My screen is visible to you.
Yeah, yes.
So the question is, fifth question is compute the expression y is equal
Why?
to a into b into c plus d into e. Basically over here we have five inputs a, b,
Yes.
c, d, e,
D.
and y is the output. So you have to just go to your vi, control T, and over here I just assign variables like a, another variable is b, then it is c, d, and over here we have the e. So these are my five variables. You can make it floating type or integer type. It is up to you. Right now I'm just making it a floating type. So next equation is my a into b into c. So I just go for compound function because I want to multiply three functions.
Multiply 3.
Yes. So a into b into c, it will give me a into b into c, and I want to just add this function over here. I just need multiply of d into e. So now just add it. So this is the function. It will give me a into b into c over here, and it will give me d into e. Just add it, and over here is your final y. So this is how you can create equations inside LabVIEW. Let's check it. So let's say my a is 2, b is 3, c is 4. So 4 into 2, 8, 8 into 3, 24. And over here it is 2, and let's say it is also 2, 2 to 4. So final answer should be 20. 1 minute. I just over here, the function is addition. It should be multiplication. So right now it is 28. Okay. Okay. So this is how you can create different equations. Likewise, if you want to go with another function, that is a straight line equation, that is y is equal to mx plus c. If you want to draw this equation, I just remove this part. So in this case, again, one is my slope.
So just it is for only the multiplication, addition only. Okay.
Basically this right now I am just using multiplication and division functions like mathematical functions. If you want to generate a graph using this, you can also do it. Like in this example I will show you. Let's say over here this is my m, and another function is my mx plus c. This is my c, let's say small c.
Sir,
This
your
is my
voice breaking. Yeah.
my voice is breaking
Yeah.
still. Now
Now okay.
okay. In between your voice is also creating some problem before
Yeah,
around.
okay. We can hear.
Okay. So right now I have, this is my slope, this is my constant, and I want to just create a function y is equal to mx plus c. So over here, let's say this is my indicator, that is y, and y is equal to mx. So another variable you can initially just
Sir, actually, the sharing seat is nothing. It's okay. It's very slow. Now only I get to see.
maybe internet issue is there. 1 minute.
Internet.
1 minute. On my side, there is no issue. I think 1 minute. Hello.
Yeah, yes, sir.
Right now it is okay.
Yeah, now okay.
Okay. So over here we have our slope, then we have constant, and I just need input variable, that is x. So the function is mx. Create mx, I just multiply these, and over here is my addition function, mx plus c. So this is my expression, y is equal to mx plus c. If you want to generate multiple values, let's say, or you want to create a graph, so in that case, let's say first I just make it, let's say slope is 3, constant is 2, and the x variable is 2. So it will create a single value 8, and if you want multiple values, you just go with your loop. Okay, so over here you have to just create how many values you require. So for that purpose, I just create a numeric control over here. Let's say I want to create 10 values. Okay, and in this I just delete this x and connect it with my multiplier. Okay, so it will give me multiple values. Let's check, and I want to just connect it to my edge of for loop, and over here I just go to the control part, and over here this is a graph. There is a separate lecture on these graph, chart, xy graph. I just explain you one by one, because there are many functions inside a single graph, inside a single chart. So I just take a waveform graph over here, just connect it. When you hit on run button, it will give you the straight line, as you see over here. Basically it will create different values. If you just create a blank array over here, and inside this array you just check, there are different values according to your loop iteration. Just make it indicator and connect this indicator to this value, and over here I just drag it. When you again hit on run button, as you see, when iteration is 0, 0 goes over here, 0 into m, 0 plus 2, that is your constant. So it will give me value 2, as you see over here. If you there is a difference between graph and chart. In the case of graph, you just need a set of values. It will require array function. If you go with chart, I will separately explain you, but a short example is over here. Right now over here, this is my chart. you can connect this chart inside the loop, because it will take scalar values. Some value comes like at 1 second, at the first second, some value comes to the chart, it will plot it. But in the case of waveform graph, it will take a set of values. It require an array. Okay, so when again I hit on run button, as you see over here, this is a straight line equation, and you can arrange it also. Let's say maximum value is in this case 30.
Okay.
Okay. So
and 30 seconds.
not 30. Basically, on the horizontal graph there is a time, so I just put it 10. So using this, it is a chart. Basically, in the graph and chart there are large functions, as you see over here. These are my common plots, colors. I will explain you in the coming lectures. So today I just explain you the basics first. So this is how you compute expression. Any expression you can compute. Likewise, compute the expression y is equal to x plus 2 into log of x. In the yes.
Sorry, sir. Actually, I know how to do this. In the bending, the balance calculation, everything I do the same format method. I'm thinking the expression node, the number 6. They are mentioned expression node, right? So I'm thinking that is something different.
No. Over here there is a expression, not expression node.
Okay.
In you can make it using formula node. You can make it in expression node. I just explain you that is the part of 6th.
Yeah.
I just explain you.
Okay.
Today only. So just go to the formula node first. So over here in the expression, over here we have this formula node. If you want to create any expression, let's say y is equal to mx plus c, if you want to create. So over here we have a limitation. Hello?
Yeah, yes sir.
Over here we have a limitation of input variable is maximum 8, like as you see over here, x1 to x8. So if you want to create y is equal to mx plus c, so let's say this is my x1, that is equal to x2 into x3 plus x4. As you see over here, if the green color is there in this LED, your program is okay. Otherwise, it will create some error. You can right now x2 is, let's say, my m. You can label it according to you also. Let's say not x1, it is my y, and x2 is, let's say, it is my x, and this is my m, and this is my c. Okay, so you can change it also. So x1 is equal to, it is up to you which expression or which symbol you are using over here. So y is equal to x into m plus c. There is some error. You just go to the help also if you have some problem, like over here in this case it is a invalid formula. It just create me some error when I just make it. Right now it is again y is equal to mx plus c. In this case x2 into x3 plus c. Okay, so this is the, in this case you just need to assign only inputs, not output. Okay. So right now my formula is created. You just create controls over there for different variables, and over here just check your result.
Yes,
And
sir.
likewise, the previous case, if you want to generate multiple values, you just create a for loop over here and just connect x variable with your iteration loop, and iteration loop automatically start from 0 and it goes from 0 to n minus 1, and over here is my maximum value, how many times my loop runs, and it will generate the result. And if you want to plot it, you just connect this result to the edge, or over here, not the from edge, you can also get the results from here using chart also inside the loop. Just connect it. So let's say in this case the constant is c and the slope is, let's say, 3, and the value, let's say, it is 100 times. So when I hit on run button, it will create your straight line equation. It will give straight line equation because y is equal to mx plus c is my straight line equation. In all cases it will generate. You can edit also your equation, let's say your graph like 200, you can scale it. There are so many functions, as already I discussed with you. You can change the color of it, like over here, if you want to change the color, if you want to change the style, want to change the width, everything is possible inside LabVIEW. Okay, so this is how you can create using formula node. Then we have expression node. Like I am not remembering where is the expression node. In that case, you just go to the search, you just type expression over here in the search palette. It will give you, over here we have both functions and control. Functions are available inside my block diagram and controls are available inside my front panel. Expression node, as you see over here, I just click on it, it will give me the expression node, and it is available inside the mathematics expression node. Okay, you just drag it. So the limitation of this expression node is that it will work on only one variable. Like I want to create 2x square plus 2x plus 3. I want to create this equation. I'm just writing it, x square plus 2x, 2 into x plus 3. Let's say I want to create this equation. In this equation, only x is the variable. For that case, you just go with expression node. Okay, so over here I just put, and the functions supported by this expression node, you just go to the control edge, and over here these are the different functions, and in the detailed help you can check the different functions and how to use these different functions. As you see over here, the input and the function is 2 plus x into log of x. It works on only single variable. So right now I am just creating x square. So let's say you can make it x, you can make it y, it is up to you which variable name you are using, but the variable should be same. Okay, so x into x, it will give me x square plus 2x, 2 into x plus 2. Let's say I want to evaluate this expression, and I just create a control over here, create an indicator over here, and it will give me the value according to the value of x. Let's say I just put 5, so the output should be 5 into 5, 25, 25 plus 10, 35
plus
33, not 33, 25 plus 10, 35, 37,
38
37.
plus 3 less.
It is a 2.
Oh,
It is
2,
2.
but front panel is showing 3. Okay.
Oh, okay. Oh, in the front panel it is a 3. Okay.
Okay.
Okay. Let's say it is 2. So when you just run it, as you see, the value is 37. So this is how you can use expression node. It is up to you, because all the functions are for user friendly and for user convenience. Because if you want to create this expression using different nodes, like over here, in this case you just need to x square, and then again 1 2x, then you need to just add this function with 2. If you want to just create this function, let's say over here this is my numeric value, I just connect it because it is my x into x. I just connect both the inputs, it will give me x square over here. Then I want to just multiply this value with a constant, that is 2, and I want to just add these two values with 2. So create constant, and this will give me the same output, that is from numeric 2. Let's again run it, as you see. So it will replace this part.
Okay.
If you are working with a single variable, you just go with the expression node. Okay, so this is how we can use expression node and formula node in LabVIEW.
Okay.
Another issue, it is with trigonometry functions.
Yes, sir, trigonometry.
Okay, so I just show you different trigonometry functions. So let's say you want to create a sine wave inside a LabVIEW. Okay, so like earlier case, when I just draw a straight line, it is same program. So just go with the for loop. If you want a limited sine wave, so it will create me, it will give me variable values according to my condition. Let's say this is my condition, how many values I want to plot inside a sine loop. So you just go to the mathematics, right click, functions, go to the mathematics. Over here you have elementary functions, and in this elementary function we have trigonometry function. Have you got that?
Yes, sir.
So
actually I tried to find this one only.
Yeah. Okay, if you there is no issue. If you are not remembering this, just go to search option. Over here just type sine, or just type trigonometry function. It will automatically drag you like sine trigonometry. Okay, so it will automatically drag you. The main advantage of LabVIEW is that you just need not to remember anything. You just aware of the functions, or you can say nodes. Just go with the sine wave over here. As you see over here, I just drag it from this function palette, and this sine wave, it is not actual sine wave. It will give me in radians. It will works with radians. As you see over here, when I put Control H, it will compute sine of x, where x is in radians. If you want to plot in, if you want to plot in degree, you have to create a formula which will convert radians to degree. Okay.
Radians to degree.
Yes. So right now I am just plotting it in radians only, and over here I just create an indicator, numeric indicator. It will show me different values of sine wave, and I also want to plot this sine wave. So I just put waveform chart, just connect it, and I also put some delay, because otherwise it will goes very fast. So I just create a 100 milliseconds. So let's say I put 100 values. So it will create, the function is inside this node, there is function sine of x. When I is 0, it will plot sine 0. When I is 1, it will plot sine 1 in radians. And you just check over here the values. So I just make it highlight also, not highlight, I just make it, the delay should be high. So just you can check what happened. So when I run it, as you see the values, it is not proper sine wave, because over here we have small values, like it will plot sine 0, sine 1, sine 2. If you want to plot a proper sine wave, you just need to divide this values, or you just need to change the values. Like I just show you, if you just change the frequency, and we can change the frequency using divide function. So input is divided by, let's say, 10. Every value is divided by 10. In this case, check what happened to the sine wave. Right now the frequency is changed. Let's say I just make it very fast as compared to previous one. So as you see, right now it will give me a proper sine wave. It is up to you. It depends on basically number of points available. Okay, so right now we have total number of points from 0 to 100. Plot will run from 0 to 100, and the number of points it will generate how many points?
N minus.
Not n minus 1. Basically, it will divide your frequency. It will change your frequency from, let's say, over here, when I is 1, it will plot 1 divided by 10, or
1 divided by 10.
Yes, and this value goes to your sine wave. So that over here we have number of points. Very there is very small difference between 2 points.
Small 0.1.
Yes, yes. If there is a large difference between 2 points, it will plot like this, as you see.
Yeah, it's the waveform is not clear. It's
not properly. Okay.
Properly.
If you just again change this value, and just make it control also. Change to the control. In the live example, I just just make it slider also over here. I'm just showing you. So this is my slider, the maximum value and minimum value. So in the real runtime, I just change the frequency. So this is how you can generate signals, and these signals also you can generate for real time also, or real world also, these type of signals. Okay, so this is how you can use trigonometry function. Over here we have sine function. Like if you want to convert this value, right now it is in radian, if you want to just want degree from this example, you just put your formula. What is the formula? 180 divided by 5. Yes, you just multiply this part with your, and in this also, let's say we just go with our signal processing. If you want to just change the frequency, you just write this code over here. From here you just change the frequency. If you want to just change the amplitude of this function, you multiply after this. Okay, let's check it. Numeric, let's multiply this function. Again I am just using a multiplier. The value of multiplier is again maximum 10, let's say, and over here let's say it is 300 delay, run it. So you just, this is how you can change the amplitude also. This is for frequency, this is for amplitude. Okay, this is how you can generate different signals inside LabVIEW. This is also an example of waveform chart. It is clear to you how to use trigonometry functions?
Yes, sir.
You can generate any function inside LabVIEW. It is a, let's say it is a function of tan 2 theta. If you want to generate tan 2 theta, we know the formula. You just write your code using the function. Let's say what is the tan 2 theta, or you can say tan 2x. The formula, yes, you remember the formula? Have you remember the formula?
Which one, sir?
Tan 2x.
Tan 2x.
Yes, this one. Tan 2x.
Tan
X
2.
is my variable. X is my angle.
Okay, sir.
The formula may be tan of x plus tan of x divided by 1 minus tan square x. Maybe. I just go with Google. Tan 2x formula. It is sin 2x divided by cos 2x, or there are so many formulas related to this. This is the formula. Tan 2x is equal to 2 tan x divided by 1 minus tan x square. It is the same. So let's say I want to create this formula, okay, in LabVIEW. So the formula is, for this purpose, I just go with again trigonometry function. I want to just go with tan x because I want to just generate tan x plus tan x. It will give me tan x. This will, let's say over here, this is my x. It will give me tan x. Again, it will give me tan x, or you can just multiply it with 2. Both the functions are same. It is multiplied by 2. It will give me 2 tan x. Okay. The output over here we have 2 tan x. Now I want to generate tan square x also. So I want to just go with again multiplier. So over here I have tan x.
Yes.
Then I just multiply it. It will give me tan square x.
Tan square x.
Okay. Tan x into tan x. It will give me tan x square. It will give me 2 tan x, and I want to just subtract. Yes. So 1 minus. So create constant over here. That is 1 minus tan square x, and I want to just divide this function. So this is how you can generate 2 tan x.
2 tan x. Okay.
It is the formula of 2 tan x. It will give me 2 tan x from x. Okay. So this is how you can generate different formulas, different trigonometric functions using LabVIEW. You can generate any function, any mathematical function. Okay. Right now, as I already told you, in this LabVIEW, there is no solar panel inside this. I just create solar panel. I just show you the code I already built inside this LabVIEW. 1 minute. So over here, this is the code. Basically, inside any model, we have mathematical equations. Using these mathematical equations, I just build this one solar panel, one solar cell inside the LabVIEW. Using this, I just got the solar panel output in the form of current, voltage and power voltage. You can generate any. I also create a PSO, particle swarm optimization technique. So you can generate any type of, and as you already told me, your main focus is on visa, right?
Yes, your hardware configuration.
Hardware configuration. Have you GPIB controller with you?
Currently no sir, but in office I have GPAB controller.
Currently you do not have, because in my Air Force project we just purchase that GPIB bus controller, or we just suggest Indian Air Force that purchase your GPIB bus controller. You just connect your instrument with GPIB bus controller, and we just create a code in the LabVIEW, and they just configure the COM port inside that, and the readings comes from their instrument to the PC, and it will record it into our system. You can also create a Google form using LabVIEW. You can store your values using LabVIEW. As you over here, I just go back to our case of chart. I just show you how to store different values. Let's say when I just run it right now, these values are already stored in this chart.
Okay.
And I just show you how you can access these values, and you also go with string function. Using this string function, you can create a Excel report also. It may be TDMS file, it may be Excel file, it is up to you. It may be CSV file. Right now 100 values are there. It will stop at 100 value. As you see, the data is available in the graph. If you want to generate into Excel, just export data to Excel. If you have Excel inside your PC, it will automatically open your Excel sheet, and your data is available. That is the data available in this chart is also available in Excel. As you see over here, my Excel is open, and the values right now, the initial value is from 437, and it is started from 438, and it goes up to 100 values, as you see. So this is how you can store your values that are generated in your chart or graph. And I also show you how you can store different data, like from a sensor. I just show you a temperature sensor. That temperature sensor, we record the data from temperature sensor through our Arduino or through our NI DAC card to our PC. How we can do that in the future lectures, I will show you, and how to generate a report also. Okay. So this is how you can go with your trigonometry function. It is clear to you?
Yes, sir.
Okay. So in this Excel sheet, maybe it is all the functions you can create, like the length, breadth of a triangle if it is given, radius of a circle if it is given. You can generate the parameter, you can generate the area. It is very easy because it is a formula based questions. Just right now, if you just create this function, basically in all these examples from 1 to 17, there are mathematical equations just, or mathematical formula. You just create, you just analyze first, then you create. Like as I create a 10 2x formula.
Yeah,
okay.
I
So
try
like
to finish it.
Okay.
Up to 17 bending items.
Okay. So right now the questions are more, because over here it is very easy, like convert a binary number to decimal number. I just show you how to convert binary number to decimal number. So just go to your VI. So let's say I want to generate a first I want to generate a 4-digit number. Okay, 4-digit binary number. For that purpose, I just place push buttons, because in the case of binary we have
0
1 0 1 only. Okay, so these are my 4 digits. You can remove its labels also by clicking this. So let's say it is my 0 position, 1 position, 2 position and 3 position. Okay, so in the case of when we go with binary to decimal, we have a base 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. We have to just multiply. Okay, so I just go with converter. In the Boolean expression, we have Boolean to number converter. This is a Boolean to number converter, as you see.
Okay.
So you just connect it with your function. So when you press it, it will generate 1, and 1 it will convert. This function will convert Boolean value, that is true, false, to 0 1. Okay.
Okay.
So if you want to check, I just create a indicator over here. So right now it is in off condition. When I hit on run button, it will generate 0. When it is on, it will generate 1, as you see over here.
Okay.
Okay, so it will generate 0 1. So I just delete this indicator. So I want to just connect this converter with every function or every digit, because I want to add these for decimal number.
Okay.
Because we know the logic, if we have a 4-digit number, we have to just multiply 0 position value with 2 raised to 0, 1 value with 2, this value with 4, this value with 8, or the function is 842, 8421. Okay, you just need to multiply this. So I just need multipliers. So connect it. As many exercise you try, your hand in LabVIEW will clear, or your base is very strong as you go through these exercises. I have around more than 500 exercise.
Okay.
So over here I want to multiply it with 1. I want to just multiply it with 1. Okay, 1 into 1 will give me 1, 1 into 0 will give me 0, because at this position I want to just place 1, and over here the constant should be 2, over here the constant should be 4, and over here it is 8. Okay, and now you just add all these values. Go to the compound function, not interest. Add these values, and it will give you a 4-digit binary to decimal converter. So let's check what happened to it. So first, let's say I just place 1 0 0 0, and if you want to also place, or you want to check using LEDs, just place LED. It is up to you how you present your program. So just connect this. This is my 0. And this is my, and also just change the labels. And right now, as you see over here, these are not at the same level. If you want to make it same level, just align according to your, like over here, top edge, vertical center, bottom edge, just. And if you want to align at equal distance using this. These options are there. These are for decoration only. So right now I just when hit on run button, it will give me value 8. As you see over here, 1 0 0 0 is there, and I just make it on 10. Now 14. Okay, so this is how you can create binary to decimal converter. And the exercise for you is reverse, decimal to binary converter. How we can go with? You just generate. Have you learned of digital electronics?
Yes, I remember that how to change binary to decimal, decimal to binary.
Not this is not the question. I just want to want to know that have you heard about subtractor, half adder?
Yes, yes.
Okay.
Half order, full order.
Okay. The function is same. Over here, you just create half adder, half subtractor using these gates, because at the end we have gates inside the half adder, half subtractor. Like in the gate also, we just have a question like with how many NAND gates you create a half adder, half subtractor. Okay. Hello.
Yes, yes.
Okay.
Hello, sir.
Yes.
Can you hear me now? Yeah.
Hello. Hello,
sir.
Yes. Is there any delay?
Yes, I don't know. In between, I think. Yes, I think it's a voice breaking. I think network problem. I'm not sure.
Okay. You are using Wi-Fi or mobile network?
Yeah, Wi-Fi.
Okay. I'm also using Wi-Fi, Airtel fiber. Maybe some network delay is there. So using
clear.
you have to just create these functions. Just try your own. If you have any problem with these exercise, just ask me. I will explain you. Okay. So over here we have related to Boolean expressions, like these functions are related to your mainly digital electronics, like SR flip-flop, how you can create SR flip-flop, JK flip-flop, AND gate, NAND gate. Okay, so I just close this one. So this is up to you. So number of exercise right now is up to 40 for you.
Yes.
Okay. So right now I just go to our next problem, that is in the case structure. What do you know about this case structure? Please explain me.
Yeah, we are doing only case structure for two functions we can use. We need to for two separate function we can use for the case structure.
Only two.
We are testing only two only, sir, in the previously.
Okay.
In the previous class we explained only two only, one for true function, one for false function.
Okay. So today I will explain you the complete functionality of this case structure. Basically, this case structure is you can equate this case structure to your notebook. Like in the notebook we have different pages. Okay.
Yes.
You just on the front part you have indexing like 0, 1, 2, 3 for the pages. You just select the page number, like on the 15th page, let's say we have a digital electronics subject. From 60th page onwards we have control system subject. Likewise you can create over here. In the default case it is only true and false, as you see over here. Okay, I just also explain you how to create a 7-segment display using this case structure. In the 7-segment display we have total number of cases. How many?
7.
Not 7, it is 0 to 9.
0 to 9.
Okay, because it is a 7-segment display, it will generate from 0 to 9. Okay, so I just explain you how to create. So first, in the default case it has only two values, true and false.
True, false.
Okay, you can just create over here control. You can make as in the previous lecture, last lecture, I already told you the LabVIEW functions are polymorphic function. You right now it is a Boolean type case structure. It has only two functions. It have only two functions, true and false. If I just go with again
0
case
1.
structure, if you want to make it 0 1 2 3 4 5, you just go over here, create a numeric control. It should be integer type, because case structure it will not support 1.1 1.2, but in that case, if let's say you have I'm just taking an example, let's say I have a case. In that case we have 1 to 10 total number of cases, and in the sub part we have 1.1 1.2 1.3 1.4 1.5 2.2 2.3 2.4. So total number of cases I want to calculate first. Let's say in this case total number of cases is 100. You just create total number of 100 cases, because the case structure will not support floating values. Okay. So I just make it integer type. Just connect this. As you see over here, when you connect it to your case structure, 0 is your default case and 1 is your true case. Okay, 0 1. It is up to you how many cases you want to create. Just add case after add case after add case after. Using this you can create as many as cases, or you can say as many as pages in your register according to your problem. Okay, so right now let's say I want to create a calculator. Okay, so true and false case is maybe clear to you already. In this case also we have two functions, like over here true and false. I just remove it. Over here 0 comma default is there. You just edit it also. If you want to edit it, just make it, let's say 25. It is up to you. But in the case structure, you just make a default case. If you have number of cases more than 2, in that case you just make a default case also, because if you want to just put, I just show you example also. Let's say over here right now I just put 25 in the case of default, and I just put a constant inside this, and this constant is 25. I want to just put, I just connect this to the edge, and over here this is my indicator. Okay, so you just check what is the function of this default. In case of 1, I just create a constant, it will generate 1 value. In the case of 2, it will generate 2 value. In the case of 3, let's say it will generate 3, and in the case of 4, it will generate 4. So right now I just continuously run it, and over here 0 is not a case inside my case structure. It will display 25, that is default. Okay, if I just put 1 over here, it will generate 1 value. If I just increase it to 3 4, 5 is not there. In the case of 5, it will generate 25. Okay, so this is the function of default. So in the case of case structure, when you go with numeric function or numeric case structure, you just make a default also. Okay, so this is how you can go with case structure, and you can also generate a range also. Like if I want to generate from 1 to 10 values, if I have a temperature, let's say I just make a case of temperature sensor, and in this case I just again create a numeric control over here. If you just connect here we have a quotient dot. As you see, it will convert your floating value into integer value, and in every program we just want to ignore this, not ignore, we just solve this quotient dot, because when you run your program, this quotient dot will produce a delay inside your program, because at this place you just your LabVIEW program will convert floating value to integer value. You just change this to integer value, and right now there is no delay inside your program. It will make your program heavy if quotient dot is available inside your program. Okay, so I just change it to 0, and I just show you the range. So in the case of 0, let's say it will generate 0 value, and in the case of case structure, if you have 100 cases, you have to create program for 100 cases also. Okay, if you left any case, like over here I just create indicator for this, I just connect this to the edge and I just go with 1. Over here it is not connected, I just want to connect it again. For 2 also connect it, 3 also you have to connect it. Every case should be connected, or you can make it default. Just right now I want to just not to create any constant or not to create any value for it. Just right click over here, just use default if unwired, create, and the symbol goes like this, square box inside a dot. Okay, so it will generate a default value, and the default value in my case it is 0, as you see. Okay,
0.
so 4 and beyond 4 it will generate 0. Okay, if you
0.
want to check it, just create constant. If value 1 is there, 1, 2, 3, and when 4 is there, it is 0, as you see. Okay, and now the function of range, how to go with range. So right now it is from 0. In the next case, let's say 0 should be from 0 to let's say 20. I want to just make over here 0 dot dot 20. It will one value will be generated from 1 to 20 values. Then over here, let's say it is, because 20 is already in our previous case, so from 21 to let's say 30 it will generate 2, and from 31 to let's say it will generate from 53 value. Okay, so and for 40 not 40, my previous value is 50, so let's say 50 to 50, let's say 60, it will generate our different value, that is let's say 5. Okay, so this is the range, and when I again run it, over here we have a broken arrow. It will, okay, because right now 31 to 50 and 50 to 60 same case are there, so you have to change it, because at the 50 value 50 value is in different cases, in both the two cases, over here, over right now it is okay, broken wire goes. So continuous run, it will generate when I already told you from 1 to 20 it will generate 1, as you see. So when I go for 21 it will generate 2, as you see. So this is how you can go with range function in case structure. Okay. right now it will generate, and beyond 60 it will generate default value, that is 0.
Default value 0.
Yes.
Okay.
So this is the part from your case structure, that is from numeric value. And if you want to generate string value, you can make it also string type. Just make a case structure over here. If you want to just type any name, and it will just search from your case, and according to your case it will generate some key value or something that is according to your application. So first I just create a string control over here, go to the string, and it is a case sensitive. If you just over here put capital letters, it will search for capital letter only. If you just go for small letters, it will search for only small letters. So in the default case, let's say it will search A. Then in the true case, let's say it will go with Salim. You can add another cases also. Let's say your name is Satish, let's say. Okay, so you just generate any message inside this. Let's say string constant hello, welcome all.
Sir.
Okay, let's say I put a message. When I just put Satish inside this input string, it will generate a hello message, hello, welcome to all. Okay, so over here, let's say it is my indicator. This is my indicator. Okay, then in the Salim, let's say I just put a message, good night. And in the default case, hello everyone. You can put any message, it is up to you. So when I just hit on run button, continuous run, because right now it is not, there is no value inside this, so it will generate default value, hello everyone. Okay, so when I just put inside this Salim and enter it, it will generate good night. Not, it is Salim. 1 minute. Maybe some error is there. Salim Satish. So again run it. Maybe some error is there. Good night all. Satish. So let's go with A. Hello everyone. Satish. There is some error.
Yes.
1 minute. The case is selected, but it is not generating the value. Let's check for capital letters. In the case structure, we have very case sensitive options. Right now I just edit this default value over here. Maybe it will create some error. I just again create a case structure. Let's check again. 1 minute. String constant. In the true false value, I just put A. In the true cases, let's say I just go with only 2 values first. Constant value. it will generate a create indicator, and in the case of this it will generate only 2 3. Let's check it for first. Run it. When B is there, right now it is working. So I just stop it and make it again to Satish and Salim. So here Salim is there, and add case after Satish is there, and in this case let's say it will generate BBB. Okay, so right now again I just run it. Right now B is there, it is not in my case, so I just put Salim over here. Just go with, as you see over here, A is there, and when I go for Satish, it will generate BB value. Again I just put enter. When you just put enter, it will create some error.
Okay.
You just put your value and click outside the indicator control. Satish, as you see. Okay, so this is how you go with string control case structure. Okay, so I just show you one CLAD question also. 1 minute. This is a CLAD question. So these are the different questions asked till now from NI in the CLAD. So as you see, these are the types. As you see, it is visible to you. What value will be displayed in the case of
value? I cannot see, but I can see some array tables.
Yes. There is a input array. There is 2 input array and indexing, and they just want the what is the output array after this replace array. So there are some options. Again, these types of questions are asked in CLAD exam. I just show you the case structure example. 1 minute. I just have the figures also. CLAD questions. They just ask like over here. This is a build array function. I just explain you in today's lecture also. So what is the output of this function? So I just go with our program one by one. I just explain you. So as you see over here, what does the indicator array look like after this VI has run twice? If I run this program twice, what is the output? So I just first create this array or program inside my loop. So as you see, this is my for loop, and these functions, as you see over here, up and down arrow will indicate your shift register. Okay. Have you heard about this?
Yes, digital electronics.
Okay. In the digital electronics, it is little bit difference. There is a little bit difference between these shift register. Basically, these are nearly your up and down counter. I will show you. How it will work. So first, I just explain you this CLAD question. So if you want to just add your shift registers, you just go to the edge, add shift registers. There is the option. These are my blank shift registers. Okay. These are my blank shift register. This is my down. This is my up. And in the array function, these functions are already discussed in my previous lecture. Today I just explain you build array function. So this is my build array function. Just I want to connect it to iteration. As you see over here, and this is connected to over here. So right now my VI is created, and over here this is my indicator. Let's check what happened. The question told me what does the indicator array look like after this VI has run twice. Mainly in this case you have to run this arrow 2 times. Okay, when you run this array 2 times, what happened to it? So when I just go with first time, as you see what happened to here, I just explained you. In the default case, this shift register have a default value 0. Okay, 0 from here, 0 from here. It will build an array. It will build an array from these values. So when first time, basically my loop will run from 0, then it will run 1, then it will generate 2 value. Okay, in this case, when you hit on run button, my iteration will go with 0, 1, 2. So first time when I hit on run button, it just build a array of these values. So first time in the first iteration, 0 is there, 0 comes from here, there is no value inside this, so 0 at 0 position, as you see over here. In the next iteration, 1 is there, 1 will be placed at 1 indexing, 2 will be placed at second indexing, and when you again hit on run button, same values are generated, as you see. 0, 1, 2, 0, 1, 2. The function of this shift register is that it will store the value, it will store the previous value. Let's say in mathematics we have to generate let's say n, n minus 1, n minus 2, n minus 3 values. You just go with this function, that is your shift register. I will show you. Let's say I just it is explained to you, this question.
Yes,
it is clear to you?
Yes, clear.
Okay, so now I just explain you the function of shift register in detail. So you can create shift register on while loop or also for loop. So just add shift register. It is a blank shift register. You just create constant. First you have to assign some value, like assign, make it integer type, make it floating type. It is up to you. Okay, so let's say I want to explain you the n, n minus 1, n minus 2 function. Okay, so in that case I want to just add 2 values. I have a operation of addition. It will add my different functions. Okay, so it will generate 0, 0. It will give me 0 in the first iteration. When I over here, this is my I, and over here is my 0, and this is my output. Let's say it is y. I just place a indicator over here to show you what value is there. Okay, so it will generate 0. So in the next iteration, when 1 is there, so over here I is 1, over here this value, that 0 comes from here to here. It will goes from this up counter to this down counter in the next iteration. Okay, so when 1 is there, 0 goes from over here, 0 plus 1, it will give me 1. Okay, when I is 2, from here I got the value 2, and from here this value goes to over here, 1 is there, 2 plus 1, it will give me 3. Now in the next iteration, when I is 3, over here I have 3, and over here I have 3. So 3 plus 3, it will give me 6. So it is up to you how many values you want to generate. So to show these values, I just make a program. So over here I just create a control. So how many values you want to create, and this value is my iteration, and this value is my output. So I just create a indicator for these values, create an indicator for these values. Array 2 will give me the iteration value, or you can say previous value, and array will give me the future value. Okay, so when you generate, let's say 10 values, so when you hit on run button, as you see 0 0 1 1 2 3, when 3 iteration is there, 6 4 10 5 15, basically it will add up your previous value. 5 plus 10 15, 6 plus 15 21, 7 plus 21 28, 8 plus 28 36, like this. And if you want your last values, so basically over here, let's say it is my n value, I just make it n, I'm just forcing it. So this is my nth value, just make it nth value. Over here we have n minus 1 value,
n minus.
Okay, and if you want n minus 2, n minus 3, you just select it and drag it. It will give you n minus 1. This is my n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7. If you want to check, just create indicator. So I just make it, let's say this is my n minus 2 value.
Okay.
Okay. And over here, this is I just again create an indicator for this is my n minus 1 value.
N minus 1, n minus 2.
Okay. And over here, this is my nth value. So if you want to just place some delay inside it, let's say it is 2-second delay, and again there is some error, because if you want to in this case you have to just connect all these functions. I am just reducing it, just checking the error. Where is the error? Over here.
N
just create indicator. Okay, so you have not initialized some. Okay, you have to just initialize every value, like over here. So first initially it is 0. So when you hit on run button, so from here you can check values goes from this to this to this, and if you want to just create for more, just go for n minus 3 also. This is n minus 3, let's say, just also initialize it, and when I hit on run button, just check. After 2 seconds delay, 0 1 1 goes to next value, 1 goes to next value, like this. The values goes from n to n minus 1, n minus 2, n minus 3. Basically there is a time instant. Okay, you can compare it to, you can generate Taylor series, you can generate Fourier series using these functions. This is how you can go with your mathematical functions. In the our Taylor series or in our exponential series, we just need these n minus 1, n minus 2, n minus 3. You can get these values from over here. Okay, so this is the function of your shift register. You can make it floating type, you can make it string type, it is up to you. It is clear to you?
Yes, sir, clear.
So this is the function of shift registers. The case structure example I just show you over here. Numeric control is set to 2.5. Yes, numeric control is set to 2.5. Which case will execute? Please give me the answer.
No, sir. Case structure is floating point is not acceptable.
Basically, floating point, you can connect floating point, but case structure will take the value only integer type. 2.5 will be converted into integer type. Okay. And according to your 2.5, it will generate
2.
What value?
Sorry, 3. 3.
3. Let's check. Let's check. Just go with the case structure. Let's check what is the answer. In the case structure, 1 is default, 2 and 3 is there.
Yes.
1 is the default, and over here this is my 2, and for the output purpose I just put some constant inside it, otherwise it is not possible for me and you what is the result. So let's say inside this value is 1, and inside 2 let's say it is 2, and in one more case would be there. Inside this, let's say there is a 3. Okay, so when 1 is there, it will generate 0 value, or let's say it is 1 also. So it will help us. So right now the value should be 2.5. Okay,
2.5.
so now when I hit on run button, it will generate 2.5. According to 2.5, it will generate 2. And when it is 2.6, let's check.
2.6, yes, correct. 2.6 is showing 3.
Okay, so this is the function, and this is this type of problem we got in our CLAD exam. So 2.5, it will give, it is nearly 2, and when it is 2.6, it will upper bound it to 3. Okay, and according to that, it will generate that function. So the answer is in this case 2, B.
2.
Okay, so this is the important question. For each of these case structures, all cases are shown. Which code will execute the case labeled case 1 of 2? Which will generate case 1 of 2?
1 of 2.
Yes, this is the question. I just minimize. Which will generate case labeled case 1 of 2. Just go with all the options. In the first case, as you see over here, case labeled case 1 of 2 is mentioned in this case. 1 is there and default case is there. So 1 is there. In the case of default, it will generate case 1 of 2. But over here, case 0 and case 2 will generate case 2 of 2.
Case 2 of 2.
If 0 is there, but in this case 1 is connected to this. Okay, so case 1 of 2 will generate in the first case. Let's we just just suggest answer is A. Let's go with another answers. In this case, 1 is there. 1 is connected to your case structure, and in the case of default, case 1 of 2 is there, and in this one, when case 1 is there, case 2 of 2 is there. So in the case of B, case 2 of 2 will execute because 1 is there. Okay, have you clear?
Yes, sir, clear.
In the case C, we have 0 is there and we have default is there. In the case of default, because 1 is connected to the case structure, it will generate default case, that is your case 2 of 2. Again, this is not your answer. Let's go with D. 1 is connected to your default case 1 of 2, and it will generate from 0 to 2. If the case is 0, case is 1,
0.
Case of 2, it will generate case 2 of 2. So our answer is A. Okay, so this is how you can go with case structures. So let's go with our different part, that is the 7 segment display. You just generate your 7 segment display. I am just explaining you how you can create your 7 segment display. You just try your own also. So first you have to use your square LED. just drag it. Okay, so this is my first LED. In the case of 7 segment display, we just need 7 LEDs. So you have to just put according to your front panel inside your block diagram also. So this is 1, 2, 3. Then I again need another LED. Another LED. Just copy it. Change the shape of this. Just make it smaller, or it is up to you how much width. Second, so let's say this is your 7 segment. You just select all these LEDs and just remove its label. So right now it is my 7 segment display. This is my this position, this position, this position. You just make it like this also. All the LEDs position should be same at same place in the front panel, in the block diagram. Now just go with the K structure. So over here, this is my K structure. Just make it numeric type. Change it to integer. Connect this. Add cases to it, because in this case the maximum number of cases are up to 9. 0, 1, 2, 3, 4, because it want to display 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Add case after. So right now this is the case. In the case of 0, we have to just make this LED off, other should be on. So it will generate a 0. So for that purpose, I just go with the Boolean constants. So in the Boolean, we have true function, and I just copy it, and this is my false function. So you have to connect all the LEDs to your edge of your K structure. All the LEDs. Okay, because in the K structure, it will generate different signals according to your cases. I just connect these. Right now, this LED will connect to false, because it will generate false signal. All other should be true. Just connect true.
Okay, sir, understand.
Okay, so this is the case of 0. Now you just go with the 1. You can generate 1 over here, or you can generate 1 over here. So it is up to you. So again, put true and false. So right now all the functions should be false except 4 and 5. So I just connect 4 and 5 to true. So this is my 5 true. All other should be false. Okay, all the now you go with 2. Same procedure is there. True. And over here this is false. So 2 should be like this. This one and this one should be off. So 6th one and 5th one should be off for 2. All other should be. In this case, when you connect these type of LEDs or this type of structure, you need your tool palette. So you just make it wire type, and in this case it will automatically save your time. Okay, so it is connected to true. So again it is connected to true. It is clear to you?
Yes, sir, clear.
Now I just go with, so should I create all the cases?
No, sir, I can do.
Okay, So now I just told you how to make it automatic. So right now I just remove all these case, delete this case. In my case, it is from 0 to only 3,
Only 3.
because if you want to connect all these cases, it will take time.
Will take more.
Okay, so I just delete. Right now my broken arrow goes and it is okay, so it will generate from 0 to 2 only. So now
Yes.
when you hit on run button, it will generate 0. When it is 1, it will generate 1. When it is 2, it will generate 2. So now I just tell you about how to automate it. You just delete this, go with for loop, connect this for loop with your case structure. It will generate 0, 1, 2 automatically, and over here I just put the maximum value, that is 3, because it will generate from n minus 1. So maximum value for this iteration is 2, and if you want to generate automatically many times, you just make a while loop over here.
While loops. Yeah.
Okay, so just create control over here, it will generate while loop, and if you want to move it slowly, you just put a delay, timing delay over here. Let's say it should be 1 millisecond, and when you hit on run button, as you see, maybe some error is there. 1 minute. It is you have to just put this over here, control B, 0, 1, 2. It will generate 0, 1, 2 as many as time according to your while. Okay, so you just create for 9 value.
9 values.
Okay, then if you just create this VI, after that I just told you how to go with multiple values. Like in this case we have only single digit number, then we go for 2 digit number, 2 digit number, 3 digit number, 4 digit number. How you can go with, I just told you. The concept is same. Okay.
Okay.
So this is all about for today. In the next lecture we will discuss further. Tomorrow maybe there is no class, and if I just may send you a message before 5 p.m. tomorrow if there is a class or not. The class will be on next day. Okay.
Okay.
If it is, are you available on Saturday, on Sunday?
Yes, available in the night time. Available.
Only in the night time.
Yes, morning I go for my son have some classes in outside.
Okay. No issue. Okay. On the Sunday, I will take this LabVIEW class that is available on that is for tomorrow. In the place of tomorrow, I just go with on Saturday.
Okay, sir, no problem. Okay, sir.
I just message you.
Okay, sir.
Have you any doubt for today class?
No, sir. If anything, I try for the bending exercise and then the 7 segment display.
Okay.
In case of any error, I message you, sir.
Okay. Just your main focus on case structure and shift register in today's lecture. Other we have a different expression. We just try these VIs that is available on, and if you want to go with different examples over here, I just stop it first. If you want to go with different examples, you just go to help. Over here we have examples, find examples. In this examples samples, there are inbuilt examples from LabVIEW. Like for array there is example, different examples are there, like over here search, go to array.
Okay.
If you want to go with array function, over here there are different examples like array to cluster, how to convert array to cluster, how to go with array to spreadsheet string, how to go with build array function. So over here we have some sample examples, not all, some sample examples. Like if you want to go for loop, you just
Yes, sir.
put for
Yeah.
loop inside this, it will give you the example of for loop. Okay, so
Okay.
this is all about today's lecture. Thank you. I just share you the video related to this lecture.
Okay.